Let's go ahead and take a look at the Unit 6 review. The first problem here says, represent the shaded part of the fraction bar as the product of a whole number and a unit fraction. All of those words are important. Product means multiplication. Whole number means a whole number. And a unit fraction, remember, has a numerator of 1. So let's take a look at this. I notice it's 1, 2, 3, 4, 5, 6. 6 1/8 have been shaded in. So I can represent this as 6 times 1/8. I have the whole number, I have the product, and I have the unit fraction. Equals 6/8. 6 1/8. All right. In the morning, Naomi jumps rope for 1/4 of an hour. After lunch, she jumps rope for another 2/4 hour. How long does Naomi jump rope? Write an equation, then solve. So we could say something like this. We use J for jumping rope. J equals 1/4 plus 2/4. All right, add those two together and write the solution in there. All right, now what we're going to do is use these fraction tiles. So let's look at this carefully. It says 10 over 10 equals 5/10 plus 3/10. Well, 5/10 plus 3/10 is 8/10. What do I have to add to it to get 10/10? I have to add this one right here, 2/10. All right? So take a look at each one of these carefully and supply the missing fraction. Number 4, Caesar buys dog treats and cat treats. He buys 7/8 pounds of dog treats. Okay, got it. This is 5/8 pounds more than the weight of the cat treats. It's telling me that the dog treats weigh more than the cat treats. How many pounds of cat treats does he buy? Write an equation. So I think that if I know the weight of the dog treats, 7/8, and I subtract out the 5/8 that it's greater, should tell me the weight of the cat treats. All right, so if I subtract 7/8 minus 5/8, I get 2/8. So let me think this through. It says if the cat treats weigh 2/8 of a pound, and I add in the 5/8 plus 5/8, that's 7/8, which is the weight of the dog treats. Okay. Number 5, a recipe calls for 2/3 cup of mushrooms. Day uses 3 times as much mushrooms. Choose the number of cups of mushrooms he uses. Mark all that apply. So I know that the recipe calls for 2/3. He uses 3 times that amount. Let me figure out what that would be. That would be 3 times 2/3, which would be 6/3. I also notice here that 6 divided by 3 equals 2. 2 wholes. So let me see what I have over here. 5/3 cup. No, that's not going to work. 6/3 cup. Yes, that's going to work. 2 cups. Yes, that's going to work. 3 cups. No. Now let's look at this one. Complete the table to show the fraction as a product of a whole number and a unit fraction. By now you should know what each one of those things mean. This is saying 5/12. That's the same as 5 1/12, or 5 times 1/12. Okay? Using this as a model, do the rest of these. Do the 2/3 and the 4/7. Now let's take a look at these problems down here. We're trying to figure out which operation is correct. Is it 6 plus 3/4 is 4 2/4? Is it 6 minus 3/4 is 4 2/4? Or 6 times 3/4 equals 4 2/4? So I've started one up here like this. And I'm saying, okay, 6 plus 3/4, this one right here, 6 plus 3/4. If I add 6 plus 3/4, I get 6 3/4. So that doesn't work, right? How about 6 minus 3/4? Does that equal 2 2/4? Well, let's try it. I don't have a fraction up here, but that's all right. I'll just borrow and make it 4/4. 4/4 minus 3/4 is 1/4. Bring down my 5, 5 1/4. Now that doesn't equal 4 2/4. So it's probably this one here, since that's the only one left. So let's take a look at it. 6 times 3/4 is 18/4. And I don't see 18/4 here, so let me try this. Let me divide 18 by 4. 4 going to 18 4 times. 4 times 4 is 16. 18 minus 16 is 2. Bring down the 4. 4 2/4. So yes, 6 times 3/4 is 4 2/4. All right, let's try B. Now this time I'm kind of weed out some of them quickly. 3 plus 2/5 would be 3 2/5. So no, that's not going to work. How about 3 minus 2/5? Let's try that one here. Again, I can make that a 2, make this 5/5. The reason I'm using 5 is because the denominator is a 5. 5 minus 2, 5/5 minus 2/5 is 3/5. Bring down my 2. 2 3/5. It's got to be that one. All right. How about this one? 4 plus 3 3/5. 4 plus 3 is 7 3/5. Easy. Okay, that was a no-brainer. Here's 7 plus 1/3 equals 2 1/3. Well, 7 plus 1/3 is going to be 7 1/3, so that's not going to work. If I have 7 minus 1/3, let me go down here and see if I can work this out. I'm going to make this 3/3. 3/3 minus 1/3 is 2/3. And I've got the 6 here. So 6 2/3, no, that doesn't work. So it must be this one right here. 7 times 1/3. So let me see what that is. 7 times 1/3, that's 7/3. I know 3 will go into 7 2 times. Actually, it goes in 2 1/3 times. So yes, that works. All right. Multiply the expression to complete the table. 7 1/6. Okay, write it as a fraction. 7 times 1 is 7 6. There are 7 1/6. But I need to write it as a mixed number. So to do that, I need to divide the numerator 7 by the denominator 6. 6 will go into 7 one time. 1 times 6 is 6. Subtract, you get 1. Bring the divisor down underneath. You get 1/6. 1 and 1/6. Okay? They've done the mixed number for you. You just need to do the fraction part. All right? So finish those up. Now let's look at these. Are these true or false? 2/8 plus 1/8 equals 3/16? No, that equals 3/8. So this is false. 4/5 minus 1/5 equals 3/5. 4 minus 1 is 3. Yes, that's true. 9/4 plus 2/4 equals 2 3/4. Well, if I take and add these two together, I get 11/4 because 9 plus 2 is 11. So you know what? I'm going to go off to the side over here. I'm going to change this fraction into a mixed number. So let me see if this works or not. 11 divided by 4. 4 will go into that 2 times. That's 8. 11 minus 8 is 3. Bring the 4 down underneath. So I've got 2 3/4. So yeah, that works. Okay, that is true. So what I'd like you to do is go ahead and look at the rest of these problems and see if they are true or false. All right, Elias says this problem can be solved using addition. Vladimir says it can be solved using multiplication. Explain why both boys are correct. Here's the problem. Milo practices 3/5 hour every day. How many hours does he practice in 5 days? Well, yes, we can solve this as an addition problem. You just take 3/5 plus 3/5 plus 3/5 plus 3/5 plus 3/5. That's 15/5. He practices 3 hours. But you can also solve it as a multiplication problem. 5 times 3/5, there are 5 days. He practices 3/5 an hour each day. 5 times 3 is 15/5, also 3 hours. Addition, multiplication. Find the sum or difference. Write your answer as a mixed number or as a whole number. So all you have to do here is just add these together. 5 2/3 plus 4 2/3. Well, when you add the fractions, 2/3 plus 2/3 is 4/3. And you know that when you have that situation, when you have a fraction like this, you have to divide. So 4 divided by 3, 1/3. You leave the fraction here. Okay, carry the whole number up here. 5 plus 1 is 6, 7, 8, 9, 10. 10 1/3. Over here, I notice that you can't take 7/8 away from 3/8. That's no problem. You just borrow, right? Make this an 8. Add 8/8 to it. 8/8 is the same as 1 whole. I'm using 8s because the denominator is an 8. 3 plus 8 equals 11/8. 11 take away 7 is 4/8. 8 take away 3 is 5. Okay? That's how you do those kind of problems. Saturday, Jesse played basketball for 2/3 hours. Then he plays some more. We don't know how much more he plays. But he plays 2 1/3 hours altogether. How much longer did Jesse play basketball? So this denominator is real important. It tells me I need to make fraction bars that are in thirds. I know he did 2 1/3 hours altogether. So maybe I could highlight 2 1/3 hours. That means I've got 2 wholes. Okay, there's 1 whole, 2 wholes, and then I need a third. So I know that he played for 2/3 of an hour right there. That's what he played. This whole thing represents how long he played altogether. He played all the way out to here, 2 1/3 hours. This part right here represents the part that he played, the some more that he played. Okay, so that's here's 1 whole plus these 2 equals 1 2/3 of an hour. So if I take 1 2/3 hour plus the other 2/3. That gives me 2 1/3 hours, okay? So it says draw a model, then solve, explain how your model helps you solve it. You could also, just to double check, you know he played 2 1/3 hours altogether. You know he started off by playing for 2/3 of an hour. If you subtract that, you should come up with the same answer, right? One-third plus 3/3 is 4/3. 4 take away 2 is 2/3. Bring down your 1, 1 2/3. Here's the model. Here's how to do it. Just using your numbers. All right, now the problem goes on. On Sunday, Jesse played basketball for 1 2/3 hours. How many total hours did he play basketball on Saturday and Sunday? Go back to the previous problem. It says he played for 2 1/3 hours on Saturday. On Sunday, he played for another 1 2/3 hours. Add those two together to find your answer. All right, we're almost there. Rebecca's recipe calls for 3/4 a cup of milk. 3/4 cup of milk. She needs 3 times as much milk to make a triple batch of the soup. How many cups of milk does Rebecca need? The recipe calls for this, but she wants 3 times as much, okay? So I notice the denominator, very important. It tells me divide your fraction bars up into fourths, all right? So I'm going to draw a model. Here's 3/4. That represents 3/4. 1 2 3/4. 1 2 3/4. And 1 2 3/4. Okay, those are all 3/4. She just needs 3 3/4, which would be 3 times 3/4. Okay, so here's 1 3/4, here's another 3/4, and here's another 3/4. That's a total of 1 2 3 4 5 6 7 8 9 9/4. Okay, which we would have gotten up here as well. 3 times 3/4 is 9/4. Well, if I were to color all this in, all of this has been taken care of. There's 1 hole, 2 holes, and 1/4 of another one. So my answer should be 2 1/4. But let's take a look and see what it actually is. I have 9/4. If I take 9 and divide it by 4, I get 2 1/4. Okay? Use your model to write 2 equations for the problem. Well, I have it as 9/4, and I can also write it as 2 1/4. All right, let's look at problems on the bottom down here. Again, just is it yes or no? 8/13. Does 8/13 equal 5/13 plus 3/13? Yes, it does. Okay. 4/5. Does that equal 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5? Well, that's 1, 2, 3, 4, 5/5. 4/5 doesn't equal 5/5, so no. All right, so go ahead and look at each one of these problems. Be careful. All right, last page. The line plot shows the length of trails Andrea hiked last month at a state park. It's hard to see on my video, but this is 5/8, 6/8, 7/8, 8/8, same as 1 hole, 1 1/8, 1 2/8, 1 3/8, 1 4/8, or 1 1/2. Okay. Now it says Andrea hiked 3 miles last week. she could have hiked 2 1 1/2 mile trails. If I take 1 1/2 plus 1 1/2, 1/2 plus 1/2 is 2 over 2, right? Well, 2 over 2, or 2 halves, is the same as 1 whole. So I'm going to put that up here, get rid of this as a fraction, and add it. 1, 2, 3. She could have hiked 2 of these 1 1/2 trails to get the 3 miles, because 1 1/2 plus 1 1/2 is 3 altogether. Now, pick 2 of these other trails that add up to 3. Okay? I'm sorry, not 2. Pick any combination of trails that eventually add up to 3. All right? So let's think about this. Maybe I could take 1. I have 1 of these. Now I can't use multiple ones. I can't go, oh, she went 1 plus 1 plus 1. That would be wrong, because there's only 1 dot there. I can only use 1 of these. Okay? So what else could I use? Well, I notice that I have, now also you can't use this one. There's nothing there at all. You can't use that one. What if I used, let's say, one of the 5/8 ones? So now I've used 1 plus 5/8. I need to get another one to add up to 3. What could I use? Let's see. Well, so far I have 1 5/8. Can't use 1 3/8. That wouldn't work because there isn't anything there. What if I used 1 2/8? Let's see, what does that give me? So I have 1 5/8. That's 1 5/8. 2 and 5. Well, that's not going to be enough because I only have 1 or 2 7/8 here. So I'm going to have to try a different solution. I've got to try to work it out to get up to 3, okay? So I've kind of just played with it a little bit. What can you add together using these fractions and mixed numbers to add up to 3 wholes, okay? I don't want to give the answer away. I want you to try it out and see what you can come up with. All right. So select the expression that's equivalent to 2 2/7. All right, so it has to be 2 wholes plus 2/7 of another one. 1/7 plus 1/7, that's 2/7, plus 2/7 more is 4/7. Nope, that's not going to be enough. 1 whole plus 1 whole, that's 2, plus 2/7 is 2 2/7. Yeah, that's going to work. So go ahead and try these different combinations and see if you can come up with 2 2/7. All right, last one. Can you explain how to change a fraction 11/4 into a mixed number? All right, so give these problems a try, and we'll talk about them later.